Hey guys, welcome back. Today we are talking about trigonometric ratios in right triangles. So the ones that we're most familiar with are sine, cosine, and tangent. You may remember learning SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So for sine theta, that is the opposite over the hypotenuse. Okay, so sine is the opposite value over the hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. The ones you might not be quite as familiar with are cosecant, secant, and tangent, and those are just reciprocals of what we have over here. Okay, so sine, its reciprocal, is called cosecant. So this is 1 over sine theta, which just means the reciprocal of sine. Hypotenuse over opposite. Secant is 1 over cosine, or hypotenuse over adjacent. And cotangent is 1 over tangent, or adjacent over opposite. To remember which ones are reciprocals of which, I like to keep in mind that each pair has a co in it, but no pair has two co's. So sine and cosecant, cosine and secant, tangent and cotangent. Each pair has exactly one co in it. Find the 6 trigonometric ratios, the values of the 6 trigonometric ratios for angle B of each triangle. So here is angle B, and we want to know the value of sine, which is opposite over hypotenuse. So here's opposite. Hypotenuse is unknown. So it's 11 over something. So we're going to use the Pythagorean theorem to find that hypotenuse length. A squared plus B squared equals C squared. So 11 squared plus 6 squared equals hypotenuse. We'll call that C squared. So that's 121 plus 36 equals C squared. We're going to take the square root of both sides, but only the positive square root. We're not going to have a plus or minus this time, even though we're taking a square root in an equation, because the length of a triangle cannot be a negative, so only the positive square root. So that means C is the square root, the positive square root of 157. I don't think we're going to be able to simplify this at all, so we'll just leave it as the square root of 157. So opposite over hypotenuse is 11 over the square root of 157. Now by rule, we can't leave a radical in a denominator. There's no irrational numbers allowed by rule in a denominator. So we're going to multiply top and bottom both by the square root of 157. So that's going to give us 11 times the square root of 157 over 157. So that is the value of the sine ratio. On to cosine, and cosine is adjacent over hypotenuse. Adjacent to B, the adjacent leg is 6. So 6 over the square root of 157. So we're going to have to multiply by the square root of 157 on top and bottom again, or we can just look at what happened when we did that. And here, we would end up with 6 times the square root of 157 over 157. We don't have to write this each time necessarily. When I multiply this by square root of 157, I get 6 root 157, and on bottom, 157. And then tangent is the opposite leg over the adjacent leg. So that would be 11 over 6. Cosecant is the reciprocal of sine. So if I take what I had originally for sine, hypotenuse over the opposite this time, I would get the square root of 157 over 11. Secant is the reciprocal of cosine. So I want hypotenuse over adjacent, square root of 157 over 6. And cotangent is the reciprocal of tangent, so that's going to be the adjacent over the opposite, 6 over 11. Find the following ratio, and what trigonometry gives is a ratio of sides. So that means that this right here, this 2/5, is a ratio of 2 sides of a right triangle. And since it's cosine, those 2 sides happen to be adjacent and hypotenuse. So if I was to put this into a picture, it would look something like this. Here's my theta. Cosine is adjacent over hypotenuse, so the adjacent leg and the hypotenuse would look like that. And what I've asked for is secant theta. Secant theta happens to be the reciprocal of cosine theta. So secant theta is hypotenuse over adjacent, which is 5 over 2. Okay, we're given another triangle in which cotangent theta is square root of 7 over 3. Cotangent is the reciprocal of tangent, which means this is adjacent over opposite. So the adjacent leg is the square root of 7. The opposite is 3. And what I want now is sine theta, which is opposite over hypotenuse. And the hypotenuse is unknown. So I'm going to have to use Pythagorean theorem. 3 squared plus the square root of 7 squared equals the hypotenuse squared. Okay, so that is 9 plus 7 equals c squared. And I take a square root of both sides. The positive square root only. So that's the square root of 16 equals c. So c is 4. So the hypotenuse is 4. So sine theta equals the opposite, 3, over the hypotenuse, 4. If tan theta is 2.4, I'm going to make that 2.4 over 1. Now we're looking for a ratio. I can simplify this ratio and it still have that same value. So here's what I'm going to do with that. In order to move that decimal one place, I'm going to have to multiply by 10. So I'm going to multiply the numerator and denominator here by 10. So 2.4 over 1 times 10 in the numerator times 10 in the denominator is 24 over 10. And that can be further simplified because both are divisible by 2, so I'm going to actually end up with 12/5 as my simplified version of 2.4 over 1. So tangent is opposite over adjacent. 2.4 over 1 is the same ratio as 12 over 5, so my opposite over adjacent is in the ratio of 12 to 5. And I want cosecant, which happens to be reciprocal of sine, and for sine or its reciprocal, I need hypotenuse. 5 squared plus 12 squared equals c squared. I'm kind of short on room, so I'm going to take a little shortcut. 25 plus 144 is 169. And the square root of 169 is 13. So the hypotenuse is 13. So cosecant is reciprocal of sine, which means it's hypotenuse over opposite. Hypotenuse is 13, opposite is 12. In number 9, I've got sine theta equals 0.8. We'll put that over 1 and simplify that ratio by multiplying top and bottom by 10. So sine theta is also equal to 8/10, which can be simplified by dividing numerator and denominator by 2. I get 4/5. So the simplified ratio of opposite to hypotenuse is 4/5. So opposite 4, hypotenuse 5. I want cotangent. Cotangent is reciprocal of tangent, which means it is adjacent over opposite. So I need to know the adjacent length. So that's 4 squared plus the other leg, which I don't know. We'll call that b. So I've got ab squared, and then c is 5 squared. 5 squared minus 4 squared is 25 minus 16, which is 9. Square root of 9 is 3. So the adjacent here is 3. So cotangent, theta, reciprocal of tangent, which means it is adjacent over opposite, 3/4. So now we're asked to use our calculator to determine the value of cosine 28. And it does say round to 3 decimal places. So cosine 28, in our calculator, the first thing we want to make sure of is that we are in the correct mode. So mode, and we are not in the correct mode. I want to go down and then over to highlight degrees and press enter. So now I'm in degree mode. If you've got a different calculator, make sure you know how to get it into degrees mode. Okay, and then we'll clear out of there, and then simply type in cosine 28, enter. And I get 0.882, and that's 3 decimal places. After that's a 9. Anything 5 or above bumps that third one up. So I get 0.883. Okay, then cotangent. Now cotangent, there's not a button on our calculator. A lot of people think that if I just do second tangent, that'll do it, but that's inverse. That is not the same as cotangent. Cotangent is a reciprocal, not an inverse. So that is 1 over tangent, 43 degrees. So 1 divided by tangent, 43, enter. 1.072, and after that 2 is a 3, that's not enough to bump that up. So 1.072. Next is cosecant, and cosecant is reciprocal of sine, so it's 1 over sine 72 degrees. 1 divided by sine 72. 1.051, and the 4th decimal place is not big enough to bump that 1 up. 1.051. Secant is reciprocal of cosine. So it's 1 over cosine 14.548 degrees. 1 divided by cosine 14.548. 1.003. The next digit is a 1, not enough to bump that up. 1.033. And the last one is sine 41 degrees, 12 minutes, 58 seconds. Now there's two different ways we can do this, and we'll go ahead and do it both ways. I can convert that to decimal degrees by doing sine of 41 plus 12 over 60 plus 58 over 60 squared. So that would look like this. Sine 41 plus 12 over 60 plus 58 over 60 squared. .6589. So that would be 0.659. That 9 is big enough to bump that 8 up. Okay, so that 9 bumps that 8 up 1. Now the other way is just to type it in exactly as it's written right here in degrees, minutes, seconds. So here's how I would do that. Sine 41, to get degrees, this says angle right here. So second and then apse, the second angle. Option 1 is a degree. 12 minutes, second angle. Oops. Try that again. Let's clear that out and start that over. Sine 41, second angle. Option 1. 12, second angle. Option 2 is minutes. And then 58. And in angle, there's no seconds. So here's how I do that. Here at plus, there's a green and then 2 tick marks. I use alpha to get to that. So alpha plus gives me the 2 marks there. So now I've got sine 41 degrees, 12 minutes, 58 seconds equals 0.659. We'll finish this lesson with some review of what we did in yesterday's lesson. So first, we will find the lowest positive coterminal angle for an 851 degree angle. Okay, so that means an angle measure between 0 and 360. So I can do that by subtracting 360 as many times as I can until I get between 0 and 360. And I think that's going to be 2. So I'm going to just try subtracting 2 360s. So 851 minus 2 times 360, and that is 131. Okay, so there's my answer for A. I've got an angle between 0 and 360. Okay, so now I want to find the reference angle. Okay, so 131 degree angle would look something like this. Okay, and the reference angle is the angle between this terminal side and the nearest x-axis. So that will be this measure right here. Okay, now this is 180 degrees. I can find this measure by doing 180 minus this 131 degrees. Okay, so 180 minus 131. So I have 49 degrees right here, and that is the reference angle, so that's B. Okay, now this one is negative, so I actually have to add 360 in order to get somewhere between 0 and 360. So negative 78 plus 360 is 282. So the reference angle, the lowest positive coterminal angle, part A, is 282 degrees. Okay, so 282 degrees would be something like this. I've got 270 degrees here, 360 here. So here is my 282 degree angle. The reference angle is right here between this terminal side and the nearest x-axis, and I can find that measure by doing 360 minus 282. And that is 78 degrees. Okay, and then this next one I'm going to add 360 again. So 120, negative 120 plus 360 is 240. So there's A, the lowest positive coterminal angle. Okay, on a graph, that would be about right here. Okay, and the reference angle goes back to the nearest x-axis, that is right here, goes back to the 180. Okay, so this time I'm going to do 240 degrees minus 180. Try that again, 240 minus 180. And that is 60. So B, the reference angle, is 60 degrees. Okay, and we will end with changing this number of decimal degrees to degrees, minutes, seconds, or DMS. Okay, so to do that, I know I have 246 whole degrees, but I also have some number of minutes, and to find that, I will do 0.876 times 60. Okay, so 0.876 times 60 is 52.56. Okay, so I have 246 degrees, 52.56 minutes. Okay, but I can't leave a decimal in minutes, so I have to get rid of this 0.56. So I have 246 degrees, 52 minutes, and this 0.56 minutes I will convert to seconds. So I have 0.56 times 60 seconds. Okay, so 0.56 times 60 is 33.6. So I have 246 degrees, 52 minutes, 33.6 seconds. And it's okay to leave a decimal in seconds when I'm converting to degrees, minutes, seconds. Seconds is the only place where I can leave a decimal.